Hello, Leiden geometry students. With today's assignment, we're going to continue reviewing the algebra that we need in geometry. Today we're going to talk about quadratic equations. The equations we've talked about so far look like these. They're basically in the form of y equals mx plus b. They have an x in them, but if they have more than one x, they're like terms and you can combine them and you can make the equation look like one of these. We call them linear equations because when you graph them, they make a straight line. But today, we're going to talk about quadratic equations. Quadratic equations are different. They have an x squared in them. They can look like any of these equations in front of you. All these have an x squared in them. When we graph a quadratic, it makes this funny looking U graph we called a parabola from Algebra 1. Parabolas and quadratic equations are used to describe all sorts of things. They describe how things fly or fall. They're used in engineering to disperse weight, the parabola shape. The parabola shape is also used in radar dishes and flashlights. For example, the way this would work, if I make a mirror into the shape of a parabola, then all the light that bounces off that mirror will be bounced to the same spot called a focal point. So all the light that would normally go through all over the mirror ends up at this one point. That means that if you have a mirror like this, if you put something at that one point, you can cook it or set it on fire. We also see this shape in radar dishes because this shape would concentrate all the radio waves into one spot so you can get a better reception. If you work this backwards, if you put a light at that focus point, that foci, then all the light bouncing off it bounces off the mirror and aims in the same direction, which creates a beam of light, which is why in a little flashlight you always see a little mirror in the shape of a parabola surrounding the light bulb. So in front of you now are two easy versions of a quadratic equation. I'm going to do the problem on the left and you're going to do the problem on the right. The problem on the left here, we have 3x squared minus 8 is equal to 67. We treat this the same way we treated the other problems that we solved that don't have an x squared in them. We just add one more step at the end. In this problem, the first thing we're going to do is simply add 8 to both sides, and then we're going to divide by 3, just like in any other problem where we had to solve for x. We add 8 to both sides, and now we have 3x squared equals 75. Divide by 3, and we have x is equal to 25. I'm sorry, x squared is equal to 25. Now that means that some number x times itself is 25. You might know that number off the top of your head. You probably do. You were taught that since grade school. But if you don't, the way we ask our calculators to help us with this, what number times itself is 25? We take the square root. We want to take the square root of 25. And that's asking what number times itself is 25. In this case, the answer is 5 and negative 5. You probably forgot about that negative 1. But when we take the square root, we always get two answers. The square root button on your calculator is located over here. You can see it right here on the calculator the school normally assigns you guys. There's another square root symbol over here. Don't use that one. That one's a little bit more complicated. We'll get to that before the end of the year. But to use this square root, we have to use the second key and press that button. If you don't have that calculator, you can just go to Google and type square root. SQRT and then the number, and Google will turn into a calculator that does that for you. Okay, so that's the problem on the left. You're going to try the problem on the right and do that right now. Okay, so for your problem, first step would be to subtract 5 from both sides and then divide by 2, and we end up with x squared is equal to 4. Then we take the square root of both sides, and the square root of 4, what number times itself is 4? It's either 2 or negative 2. With quadratics, we typically get two answers. There are times where there's only one answer. There are times when there's no answers. But usually we're going to get two solutions. Now the problem you just solved just has an x squared in it. These problems get trickier when they have both an x and an x squared in them. You cannot combine these. They're not like terms. So we can't solve this normally. We have to come up with a different way to solve it because we have to kind of solve for two x's at the same time. In Algebra 1, you learned 3 different ways to solve these problems. Before we can solve them, though, we have to write it correctly. All of these quadratic equations are written the right way in what we call standard form. For it to be in standard form, and it must be in standard form for us to be able to solve it, it has to be written like this, where we set it equal to 0. So we take all the numbers, we put them onto one side of the equation so that it's equal to 0, even if the 0 is on the left, like this one. And we put it in order. So we have the x squared term first, and then the x term, and then the plain number. All of these versions up here have that written the same way. The x squared term plus or minus an x term plus or minus a normal number equals 0. That's the standard form. These, which I showed you earlier, are not written in standard form because none of them are set equal to 0. Here are three quadratic equations. Which one is written in standard form? Yeah, the first one is written in standard form. It's 5x squared minus 3x plus 4 equals 0. We like this. This is how we're going to solve it. The second one has the 2x on the other side, so we can't solve this one until we move the 2x to the left side. So if you had a problem like this, you would subtract 2x from both sides, and then you'd have to rearrange it so the numbers are in the correct order. So it would be 7x squared minus 2x minus 6 equals 0. And the last one, same thing. We got to move the 11x and the 8 to the other side. So we'd subtract 11x and add 8 to both sides. And then we have to rearrange it so it's in the right order. So we'd have 5x squared minus 11x plus 17 is equal to 0. Now, the first way we have to solve them is graphing. Here I have a quadratic equation. It's in standard form. We can solve this by graphing it. To graph it, though, we're going to get rid of this equals 0 and rewrite it as y equals this equation. When you have y equals the equation, you solved equations this way, or you graphed equations this way in Algebra 1, where you created these tables and found points and connected the dots and made a U-shaped parabola. We're going to take this equation, make it y equals, and instead of graphing it using points, we're just going to use Desmos to do this. So you're going to go into Desmos and graph this equation. So go to desmos.com and select graphing calculator. When you do that, you have to type this equation in on the left. Y equals x squared minus x minus 12. If you're wondering how to get the x squared part, you have to use the little up arrow that's above the 6. So you have to shift 6 and then put that exponent in. And then you got to make sure you're not writing everything in the exponent, so you can push down to get out of the exponent thing to write the rest of this. If you graph it correctly, it should look something like this. Now, again, what we did is we removed the equals 0 part, so we're just going to look at the graph and find out where the graph hits 0. Well, it hits 0 at 2 spots. So we're looking for the two numbers where the line crosses the x-axis. You can count these out. It's right here and right here, the two places where they cross the x-axis. Now you have to find them. You can count this out, or the nice thing about Desmos, if you hover over it, the coordinates will show up. It'll tell you that the one on the left here is at -3, 0, and the one on the right is at +4, 0. Those are our two solutions, -3 and +4. So again, you want to find these 2 points. Whoops, pardon me. You want to find these 2 points where the line crosses the x-axis. Find their coordinates. One of the numbers, the second number will be 0. The first number is the solution we're looking for. So in this problem, the solutions are -3 or +4. You're going to do the same thing for this problem. Rewrite this as y equals x squared plus 4x minus 60. Graph it in Desmos or on whatever graphing calculator you got, and find where it touches the x-axis, what we call the zeros of this equation. And if you do it right, we should get 6 or -10 for our two solutions. Graphing has some good things and bad things. The good thing, it's easy, it's fast, the computer does all the work. But the bad thing is, it's not always accurate, perfectly accurate or precise. It's hard to tell the difference between 3.1 and 3.2 on the graph. So if we need an exact answer, that's not always the best thing, but it's very good for getting an approximation. Next, we're going to talk about our second way for solving a quadratic equation, which is using this, the quadratic formula, which you probably remember from Algebra 1. The good thing about doing the problem this way is it's always right. You're never going to have any trouble figuring out 3.1 or 3.2. Even if the numbers get uglier, since you're still just plugging numbers into a formula, it doesn't really get any harder. The bad thing is it takes more time, and with the algebra here, it's easy to make a mistake, specifically lose a negative sign. Before we can do the quadratic formula, we have to name these three numbers. The first number that's going to be in front of the x squared, we're going to call that a. The number in front of x is going to be b. In this case, that'll be -3. That negative sign comes with it. And c is the normal number at the end. So we have a, b, and c, and we're going to plug these numbers in for a, b, and c in this big, ugly formula. So I'm going to walk you through this problem. We're going to solve this with the quadratic formula, and I'm going to ask you to do one that's just like it. All right, so step one, identify a, b, and c. A is the number in front of x squared. If there's no number there, if the coefficient is missing, then it's 1. So a is going to be 1. B is -5. Don't forget the negative sign comes with it. And c is -24. So a is 1, b is -5, and c is -24. Then we're going to come over to the quadratic formula, and we're going to replace the letters with their appropriate numbers. And if you do that properly, it will look like this. Now, I know that looks a little overwhelming at first, but all we did is replace the a's, b's, and c's with their appropriate numbers. For example, -b, well, b was -5, so it's -5. That's where that number comes from. Under the parentheses, b squared, we have -5 squared. And yes, you do need the parentheses if you're doing this in the calculator, because otherwise it'll square it first and then make it negative. So it's -5 in parentheses squared. You need those parentheses anytime the value for b is negative. And then for 4ac here, it's 4 times a times c. That's 4 times 1 times -24. Finally, on the bottom, we have 2a. And in this case, 2 times a is really just 2 times 1. Now we're going to try to simplify this. Parts of this look harder than they are. For example, all these extra negative signs out front look complicated, but that's just going to simplify. These two negative signs will just will just cancel each other out, and we'll just have 5. I'd recommend typing this whole mess that's under the square root into your calculator, doing that in one shot. If you do that correctly, the -5 squared minus 4 times 1 times -24, you're going to end up getting 121. And on the bottom, 2 times 1 is just 2. So after just one step, we get the problem down to look like this. The next step is to take the square root of this 121. You could try to merge that with the last step and take the square root right away. I always break it up, but if you're comfortable with the calculator and you don't mistype anything, you might be able to get away with that. Anyway, the square root of 121 is 11. So this is 5 plus or minus 11 over 2. At this point, you're probably forgotten about what's the plus or minus thing. Well, remember, a quadratic has two solutions. We get the two solutions, one by doing the positive, 5 plus 11, and one with a minus, 5 minus 11. 5 plus 11 is 16, divided by 2 is 8. 5 minus 11 is -6, divided by 2 we get -3. So this is going to be your problem. You can do it the exact same way as the last problem, and you can rewind the video and follow the steps and do it on scratch paper if you like. But you're going to try to find the two solutions to this quadratic equation using the quadratic formula. Okay, if you do it right, A, B, and C, A is 1, B is 2, and C is -35. We plug those into our formula. The formula is going to look like this. -b becomes -2. B squared is just 2 squared. Minus 4ac is minus 4 times 1 times -35. And then on the bottom, 2 times 1 will just be 2. Take care of this mess under the square root first. If you do that, it'll turn into 144. And then when we take the square root of 144, it becomes 12. So -2 plus 12 is 10, divided by 2 is 5. -2 minus 12 is -14, divided by 2 is -7. Those are our two solutions. The third way we solve a quadratic equation is by factoring. Factoring is just doing FOIL backwards. If you don't remember FOIL, no problem. Here's a short review. This was distribution. If I have 5 times 3x plus 2, we do 5 times 3x, 5 times 2, and we get 15x plus 10. That should be pretty easy. FOIL is what we have to do when we have two numbers that have to be distributed. See, this x minus 5 times 3x plus 2, you don't just distribute the 5, you also have to distribute the x. You distribute both terms in this one set of parentheses. So if we do x times 3x, we get 3x squared. X times 2, we get 2x. Negative 5 times 3x, we get minus 15x. And negative 5 times 2, we get minus 10. Then, as long as the problems are simple ones, which ours are probably going to be, the two middle terms turn out to be like terms. We can combine them. 2 minus 15 gives us negative 13. So 3x squared minus 13x minus 10. That's FOIL. Before we go any further, let's do a practice FOIL problem, see how you guys do. And I'm going to ask you to FOIL this out. So you're going to distribute the 2x to both of these, distribute the 9 to both of them, and combine your like terms. Okay, if you do that right, distributing the 2x, we're going to get 8x squared minus 2x. And then distribute the 9, we're going to get 36x minus 9. The 2x and the 36x are like terms. You can combine those two. And we're going to get 8x squared plus 34x minus 9 for this problem. Okay, this is FOIL. This is creating a quadratic from two sets of two terms, what we call binomials. Factoring is doing this backwards, where I'm going to give you this quadratic equation at the end and ask you to figure out what were the sets of numbers that were multiplied together. If you don't remember what this has to do with the word FOIL, FOIL was just an acronym for remembering this. F stands for first. You multiply the first number times the first number. 2x times 4x gave us 8x squared. The outsides, it's the beginning number and the final number. 2x times minus 1 is negative 2x. The inside numbers, the 2 in the middle, 9 times 4x is 36. And L is the last. 9 times negative 1 gives us negative 9. That's what FOIL stood for, but it's really just distribution. But now we're going to do it backwards. Now, these will be simple ones to start, but they can be a lot trickier. All right, so in this first problem, two binomials were multiplied together or FOILed to create x squared plus 11x plus 18. To figure out how to do this, what numbers belong here, it's going to be, because everything's positive, it's going to be x plus one number and x plus another number. To find those two numbers, we need to figure out what two numbers multiplied to 18 but add to 11. So we start listing numbers that can multiply to 18. It's 1 times 18, or 3 times 6, or 2 times 9. Which ones add to 11? One's 2 and 9. They multiply to 18, they add to 11. So it's x plus 2 and x plus 9. It doesn't matter which one's first or second. In the second problem, same thing. Two numbers that multiply to 30, but add to 11 again. So you start listing numbers that can multiply to 30. 1 times 30, 2 times 15, 3 times 10, 5 times 6, and you find which ones would add to 11. In that case, it's 5 and 6. They multiply to 30, but add to 11. So it's x plus 5 and x plus 6. Now, that step of figuring out what those two numbers are is a little bit trickier, so let me walk you through the steps on how to do that and do it well. Here's a problem that we need to factor. It's a quadratic equation, and we're going to factor it. We need numbers that multiply to 48, but add to 14. To do that, to figure those numbers out, start with the number you're trying to multiply to. Here, 48. And this is just scratch work over here on the side. And I'm going to list numbers that multiply to this. And I always start with 1 times that number. 1 times 48 is 48. I'm just going to go count up as I go through this. Can I multiply 2 by something to get 48? Yeah, that's 2 times 24. If you're not sure if 2 multiplies by something to get 48, just take 48, divide by 2. If it comes out to a nice number, that's a pair. If it comes out to a decimal, we don't use it. So if you did like 48 divided by 3, we'd get 16. So 3 times 16 is 48. And 4 times 12 is 48. And 6 times 8 is 48. Notice I got 1, 2, 3, 4. 5 didn't work. It would give me a decimal. 6, I'm going in order. The next number is 7, but 7 doesn't go into 48. And I can stop there because the next number I would check is 8, and it's already on my list. Once you start doubling back, you're done. Now we need to figure out which of these pairs of numbers, because this is all of them, which of the pairs of numbers that multiply to 48 would also add to 14. 1 and 48 is 49, 2 and 24 is 26, 3 and 16 is 19, 4 and 12 is 16, 6 and 8, hey, that adds up to 14. So 6 and 8 are going to be our key numbers. So I'm going to write this out like this, x plus blank times x plus blank, and I'm going to put these two numbers in, 6 and 8. It doesn't matter which one's first or second. Now, In this case, we're supposed to be solving the problem, so it's not even an equation. Your actual problems would have an equals 0. I took that out to make it simple for the beginning here. And here's the last step to this thing, which is easy, but maybe a little bit weird. Here, this binomial, x plus 6, times this binomial, x plus 8, equals 0. We're multiplying two things together. This set of parentheses and this set of parentheses are being multiplied together, and they end up being 0. If you multiply two things together and get 0, that means one of them was 0. So either x plus 6 was 0 or x plus 8 was 0. Which one? Both. This is where we're going to get two solutions, two answers to our problem. If x plus 6 was 0, that means x would have to have been negative 6. If x plus 8 was 0, then x would have to have been negative 8. Now I'm going to give you another problem just like this one and ask you to see if you can solve it. Again, rewind the video if you need to. Here is going to be your problem. X squared plus 8x plus 15. You're looking for numbers that will multiply to 15 and add to 8. So you write it as, in its factors, what was FOILed together, and then set each part equal to 0 and figure out what the solutions are. Okay, if you do this, only two sets of numbers of integers anyway will multiply to 15. It's 1 times 15 and 3 times 5. 2 doesn't work, 4 doesn't work, and then you're already at 5, which you've already got used here. So which of these numbers can we get to add to 8x? It's the 3 and the 5. So when we write this, it's x plus 3 and x plus 5. It doesn't matter which one's first or second. Now the whole thing's supposed to be equal to 0. So either the first part was 0, x plus 3 is 0, or the second one was 0, x plus 5. That makes our solutions negative 3 and negative 5. Now here's our last problem. It's a bit harder because not everything is positive. By throwing in a negative, it adds a little bit of a trick, but the same idea works to solve it. We're going to start with this number here at the end, 32. We need numbers that will multiply to 32. So starting with 32, it's 1 times 32, 2 times 16, 4 times 8, and 5 doesn't work, 6 doesn't work, 7 doesn't work, and then we're back to 8 where we already started. So it's one of these three sets of numbers. But it's not supposed to actually multiply to 32. It's supposed to be negative 32, which means one of these has to be positive and one of them has to be negative, and add to negative 4x. So you could do 1 minus 32 or 32 minus 1. That doesn't give us negative 4. 2 minus 16 or 16 minus 2. That won't give us negative 4. But 4 and 8 will. We can do 4 minus 8 will give us negative 4. So we're going to use that set of numbers. And for them to multiply to a negative, only one of these is positive and one of these is negative. So our terms might look like this. X plus one of them, x minus the other one. Figure out which one goes in each part so that we can get negative 4 for our answer. If you do it right, it's supposed to be x plus 4 and x minus 8. 4 times negative 8 will give you negative 32. 4 minus 8 will give us negative 4. The rest of the problem is done the same way. Set it equal to 0. That means either x plus 4 was 0 or x minus 8 was 0. So x would have to be negative 4 or positive 8.